Next, we're going to take a look at reactions of carboxylic acids. And although there are a lot of important reactions, we're really just going to mention them because we're going to look at them in more detail in other chapters. Here we have an overview of reactions of carboxylic acids. We've already seen examples of reduction, so we know that if we have a carboxylic acid, we can reduce it with lithium aluminum hydride followed by water to give a primary alcohol. Sodium borohydride cannot be used on carboxylic acids, and actually even lithium aluminum hydride, it's often not used because it can be better to reduce an ester rather than a carboxylic acid, but it can be done. Another very important reaction of carboxylic acids is deprotonation. In other words, we're talking about an acid-base reaction. A base grabs off a proton and we make our carboxylate. Carboxylic acids can also undergo a reaction called alpha substitution. So rather than a reaction happening on the carboxylic acid, it happens adjacent to the carbonyl. And this, if we focus on the carbonyl carbon, this would be the alpha position. So an alpha hydrogen can be substituted by another group. This is alpha substitution. We're not really going to worry about that. Another important one is nucleophilic acyl substitution. So rather than having our carboxylic acid, we will keep the carbonyl, but the OH is converted to something else. So carboxylic acids can be converted to acid chlorides, and then acid chlorides can undergo nucleophilic acyl substitution to give a bunch of different compounds. Or carboxylic acids can be converted to esters, and that one is a very important nucleophilic acyl substitution reaction. We're just going to look at an example of that. So one of the most important reactions of carboxylic acids would be esterification. And in particular, when we have a carboxylic acid and we react it with an alcohol in the presence of sulfuric acid or some other acid, this is called a Fischer esterification. And one of the important mechanistic questions, so if we have a carboxylic acid and an alcohol, we are going to make an ester. So we have this piece that comes from the carboxylic acid, we have this piece that comes from the alcohol, but is this oxygen from the acid or from the alcohol? And trying to determine this mechanism was really important in terms of understanding the mechanism of many nucleophilic acyl substitution reactions. Here is another example. This is called isopentyl alcohol, and this is acetic acid, so this can undergo Fischer esterification to form isopentyl acetate, which is in banana extract. So I just want you to be aware that carboxylic acids can be converted to esters, and we're going to talk about how this works and look at many more examples and look at details in the next chapter.